Using properties with rational numbers is how we can find equivalent expressions or equivalent equations. And what this means is that you can show the same math phrase or the same math sentence in different ways. This is useful because it makes certain equations easier to solve, or it gives us multiple options of how to find a total cost or a total number of hours or all kinds of other real life applications. A major property we're going to be using is the distributive property. So to refresh your memory, what distributive property says is when you have a number outside the parenthesis, I can multiply that number by each term inside the parentheses. So A times the quantity B plus C is equal to A times B plus A times C. So here's an application of this. Orlando works at a moving company. He earns $12.75 per hour. He works 4 hours on Friday and 7 hours on Saturday. Use the distributive property to find his earnings in two different ways. And if I were to just present this question to a class and I didn't even say the word distributive property, I would see two different ways that students do this. Some students will say, well, he worked a total of 11 hours. They add 4 and they add 7. They get 11. And then they multiply 11 times 12.75, and that certainly is a fine way to do that. Other students might say, well, on Friday he earned $12.75 times 4, and then on Saturday he worked 7 hours, so I multiply $12.75 times 7. You get how much he earned on each day and then adds it together. What the distributive property does is it says that both of these methods are equivalent. I can multiply $12.75 times 4 plus $12.75 times 7. Either way is perfectly acceptable. Something with this lesson that's going to be difficult for you is you want to do too much. Really, I'm just wanting you to show me equivalent expressions, equivalent equations. I'm not necessarily looking for a final answer. If you'll notice, nowhere on the board does it say how much money Orlando earned. Kudos to you if you figured that out, but that wasn't what the question was asking. The question is asking use the distributive property to find it in two ways. I want to see those two ways. Here's something that is very helpful. I do this quite often in my Algebra 1 class. Equations like this come up all the time. We've been kind to you in 7th grade, and we gave you friendly equations. They had whole numbers. We might have thrown in a few decimals, maybe some negatives and some fractions, but for the most part they were friendly equations. Equations like this are all over Algebra 1, Algebra 2, geometry. And this right here, 1/3 x minus 4 equals 2/5 is stressful. I don't know about you, but I would prefer to not work with fractions when we're dealing with an equation. So what you can do is you can rewrite without fractions by multiplying each term by the LCD, which is the least common denominator. If you'll think back to expressions, equations, I taught you that you could do anything to an equation as long as you did the same thing to both sides. This would be the multiplication property of equality. It is okay for me to multiply by 15 as long as I do that on both sides. Where does 15 come from? That is the least common denominator. I looked at my denominators, 3 and 5, and their least common multiple is 15. So I multiply each side by 15. And when I'm multiplying the left side times 15, I put parentheses around it because I'm not just multiplying 15 times 1/3, but also by -4. So when you multiply 15 times that, 15 times 1/3, the way I do that in my head is that's the same thing as 15 divided by 3, which is 5. Until you get there, though, you may think fraction-wise, 15 times 1/3, you would put 15 over 1. And you may think, oh, well, I would cross-simplify by 3s, and so that goes down to 1, that goes down to 5, and so I get 5x. And then I'm going to do 15 times 4, which is 60, equals, and I'm going to multiply the right side by 15 as well. I could cross-simplify there. That goes down to 1, that goes down to 3, 2 times 3 is 6. And now I have written an equivalent equation, but this one is a lot more easy to do than this one up here. This one is much less stressful, and I think it's worth the time to rewrite it as opposed to solve it like this, because a lot of your errors when you're solving equations come in because you struggle with your fraction rules. This gets rid of the fractions. Okay, now writing equations without a decimal. We have Maxine, and she's replacing a 14.75 meter row of wood flooring. She has already placed a strip that is 0.75 meters long. How many 1.5 meter strips of wood does she need to finish the row? Write and solve an equation without decimals. So here's where I've built my equation. 1.5x, that's representing the number of 1.5 meter strips left that she needs to finish the row. Plus, she already had a 0.75 strip placed. That needs to equal the total length of the row, which was 14.25. Very similar to what we did with fractions, you're going to use the distributive property. And to get rid of those decimals, you multiply by powers of 10. This is very similar as well to when we divided decimals. You had to move the decimal place over in the divisor, and how many places you moved it in the divisor to make it a whole number. You do the same thing in the dividend. You look at your equation, you see which number has the most decimal places. Well, I have 2 decimal places here. So for each number inside, in the original equation, you're going to move the decimal 2 places, which is the same thing as multiplying by 100 on each side. So 1.5, when I move the decimal 2 places, is 150. 0.75 becomes 75, and 14.25 becomes 1,425. We use the distributive property to multiply it by 100. And as you can see, I solved it over here, and that was much easier than having to line up decimals and set up long division boxes and such. I could do this just right here on the board without any extra help. Now time for you to practice. For A and B, I want you to rewrite those without a fraction. Don't worry about actually solving the equation. I just want you to rewrite it without a fraction. And then on part C, I want you to find 2 equivalent expressions to find Claire's cost. I'm not looking for the total cost. I'm looking for 2 different expressions. On part A, I looked for the LCD, which was 6. Multiply 6 times each term inside the parenthesis. How I did this in my head is I said 6 times 2 is 12. 12 divided by 3 is 4. 6 times 8 is 48. Over here, 6 times 5 is 30. 30 divided by 6 is 5. On B, the LCD was 15. So multiply 15 times 4 is 60. 60 divided by 5 is 12. 15 times negative 2 is negative 30. And 2 times 15 is 30. 30 divided by 3 is 10. On part C, Claire bought 11 pens at $1.39 each and 11 pencils at 79 cents each. Write 2 equivalent expressions to find the total cost. So first I found, or I went about it with the mindset of the cost of the pens plus the cost of the pencils. 11 pens at $1.39 and 11 pencils at 79 cents each. And then looking at that, I saw how that was related to the distributive property. 11's been multiplied by each of those, so I can factor that out, put it outside the parentheses. No matter what, I'm buying 11, and this is looking at it as if I bought one pencil and one pen, and I did that 11 times. And you have 11 times the quantity, 1.39 plus 79.